So 3.6 is all about transformations of graphs and linear functions. It has a day 1 on here. We might be consolidating day 1 and day 2 because that's snow day. We got to make up some time. All right, so we are going to mostly focus on translating. We might look a little bit into reflecting. Anybody need more time on this first slide? Okay. A little bit of vocab for us. A family of functions is a group of functions with similar characteristics. Remember, when you're writing these in your notes, you don't necessarily have to write these sentences word for word. If you want to just write the bold words and like put a dash after it, and put functions with similar characteristics. You can shorten some of these up. The parent function is the most basic function of a family of functions. So it's as simple as it can get. Okay, for nonlinear functions, the parent function is f of x equals x, or you could think about it as y equals x. That's the most basic line we could graph. A transformation changes the size, shape, position, or orientation of a graph. So it changes a graph. If you want to just put a transformation changes a graph, that's fine. It could change it in a lot of different ways. A translation is a transformation that shifts a graph horizontally or vertically. So a translation is a shift. It could move it up and down, or it could move it left or right. If we're just shifting it, translating it, it doesn't change size, shape, or orientation. Just slides it around. All right, so here, I understand it's small, so I'm going to write out what's important off to the side. First, we're talking about horizontal translations. So horizontal translations is up first. This means our graph is getting moved what directions? Right or left. Okay, so so if we have a function f of x as the parent, so we're going to call our parent function y equals f of x. This is our parent. This is what we're basing everything else off of. If we change it so that we have y is equal to f, and then in the parentheses, we have x plus h, where h just represents a number. This is going to shift our graph left. This is where it gets a little counterintuitive. If we're adding, we end up shifting it to the left. If y is equal to f of x minus h, then we are going to shift right. Where, again, h is just a number. So both times h could be any number, right. And we're actually going to be shifting it h units, which means if we're adding 3, then we'd be shifting left 3 units. So if you want to add that on there, you can. Both times we would be shifting it however many units it is that we are adding or subtracting. Questions, concerns, need more time on those notes. Because I got to take those away to put up our vertical ones. Notice that when we added and subtracted h, it happened inside of the parentheses, which means it happens to the input value. So it's not happening to the overall function. This is changing the input value before we evaluate the function. Last call for these before it disappears. Okay, vertical translations work a little bit differently. Vertical means we're going to be moving it where? That was horizontal.
Left to right.
Up and down. Vertical is going to move it up and down. Horizontal goes left and right. Vertical goes up and down. Our parent function, again, is going to be y equals f of x. This time, we are going to be adding and subtracting numbers outside of the parentheses. So if we have y equals f of x plus k, where again k is just going to represent a number, this is going to shift us up. Shift up, k units. What do you think happens if we subtract k outside those parentheses? It's going to shift down k units. Ooh. So again, k just represents some number. So when we are adding or subtracting inside the parentheses, it kind of goes the opposite direction of what we think. When we added inside the parentheses, we moved it left. When we subtracted inside the parentheses, it moved it right. But when we're outside the parentheses, it actually moves how we would expect. Adding moves it up, subtracting moves it down. Okay. The difference happens because we are not subtracting or adding to our inputs. We are adding and subtracting from our outputs because we're outside the parentheses. Questions or concerns about vertical or horizontal translations? Need more time on this slide. Okay. All right, so first up, they want us to let f of x equal 2x minus 1. So they want us to graph a couple different lines. But first, let's go ahead and graph our parent function. So if on your graph paper you want to write down that the parent function is f of x equals 2x minus 1. Or you could think about that as y equals 2x minus 1 might be another way to write it. Let's first graph that one, and then we'll worry about the translations. If I'm trying to graph y equals 2x minus 1, first, I want to make sure I'm in slope-intercept form. I am, so that's good. Next, we want to identify what? The m and the b. What's my m? 2. As a fraction, I could write it as 2 over 1. And my b? Good. When I start this graph, where do I go first? Negative 1 on the y-axis. Put a point. We use my slope as rise over run, so I should go up 2, right 1. I can do that. Good. I could do that a few times, or I could go down 2 and to the left 1. Either way, I should be able to get several points there. Oop, not that one. Okay. For these problems in particular, it might be nice to put several points. So I'm going to try to leave those points red and make my line through them kind of thin. So that way we know that those were my parent function points. I'm going to make them a little bigger. I think this will help us be able to shift them. Okay, so now let's look at the shifts that they want us to do, if that's my parent function. For g of x, part A, now we're looking at g of x equals f of x plus 3. Are we adding or subtracting inside or outside of the parentheses? Outside. So will my shift be vertical or horizontal? Vertical. Outside the parentheses, we move vertically. So if I'm moving vertically, am I going up or down? Up. Which one? Up, because it was adding 3. So that means from my parent function, I can take each one of these points that I made and go up 3 and put new points to graph this function. That's what it means to translate. So now that I have my parent function, I'm going to switch colors, and I'm going to go up 3 from each of those points. 1, 2, 3. And I get my new points. So from each of my points, I'm counting up 3 to get the new one. 1, 2, 3. And you don't necessarily have to do all of them, but you can show that they all got translated up 3. Okay, so if you want to make some notes about it, our thought process was adding outside meant that it was a vertical translation. Okay, since it was adding outside and we knew it was vertical, we knew we had to go up that many units. So we went up 3. And then we can plot our line through those points. That's not a great line. That's a little bit better. Again, we can put arrows on the ends. Questions about graphing the line from part A? Okay, on part B, let's kind of start our process over again. So on this one, I'll pull it down here. Are we adding inside or outside the parentheses? Inside, which means it's what kind of shift? Inside is horizontal. And because we were adding, that means which way are we going? Left. This is the one that kind of goes backwards from what we think. When we go horizontal, we kind of have to go backwards of what is intuitive. If we are adding inside, that means we end up going left 3 units. So that's from our original one. So from my red points, I'm going to be moving left 3 units. So start at a red point, go left 1, 2, 3, put another point. Left 1, 2, 3, put a point. Okay, are we all okay with how we're getting these? Start at a red point, go left 3. 1, 2, 3, and of course we don't necessarily need to do every single point. We have plenty of points to be able to see our line. But we move all the points left 3, and that is going to give us our line for part B. I've got so many points it doesn't want to put my line on there for me. It keeps wanting to drag them over to the other points. It's not great. Okay, it lined up the bottom points, but it got a little off from the top points. Questions about our shifts? All right, our next section is on reflections. So we are going to be reflecting in our axes. A reflection is a transformation that flips a graph over a line called the line of reflection. So you might want to add that in. Flipping it over a line of reflection. I'm again going to take away some of this so I've got room to write you some notes a little bit bigger. Okay, so if our parent function is, again, y equals f of x, it's our original function, and we reflect it in the x-axis, our new function is going to be y equals negative f of x. So the entire function is getting negated. All the outputs get multiplied by a -1. That's what it says down here. But you negate the whole function or you negate all your outputs. Okay, so then in the y-axis, to reflect in the y-axis would be our same parent function. Y equals f of x is still the parent function. This time, we would be negating all of our inputs. So in the x-axis, we negate the outputs or change the sign on the outputs. For the y-axis, we're negating or changing the sign on the inputs. In my opinion, this is easier than translations. You just have to be able to keep your axes straight. So again, we're given a parent function, and then we are going to graph two reflections of it. So first, we need to start with our parent function. F of x equals 1/2 x plus 1. Again, if you would rather write it as y equals 1/2 x plus 1, you can. For our parent function, in order to graph it, we need to identify our slope and our y-intercept. What's my slope? 1/2. And then our y-intercept is the 1. Good? We start graphing at our y-intercept. So I put a point where? 1 on the y-axis. So that's up 1. If my slope is positive 1/2, where could I go to get another point? Up 1 and then? Right 2. Up 1, right 2. We could do that a few times. Or, good, down 1, left 2 a few times. Okay, and we have several points that are on our graph. This is our parent function, so this is the one that they are wanting us to change as we go. Okay, if you're not using different colors, it might be helpful to label that this is your f of x line. We could label our other lines as g of x and t of x when we get to them. All right, for g of x equals negative f of x, are they changing or negating their inputs or their outputs? What do we think?
Outside.
It's outside, so those would be our outputs. Outside outputs. So if it's negating outside, that's changing our outputs or negating our outputs. So that means we're going to reflect over which axis? We just saw it on the last slide. It'll be the x-axis. I mean, it had to be one or the other, right? Reflected over the x-axis. Okay. So, one way to think about it is that if your outputs are what's changing, that means the y's are changing. Y coordinates changing. That means you're reflecting over the x-axis so that the x stays the same. Okay, so, or you can just memorize. Negative on the outside, you reflect over the x-axis. What it means to reflect is that we are creating a mirror image of it on the other side of the x-axis. So however far away we were from the x-axis, we're going to go that many units on the other side of the x-axis. So remember, your x-axis is the one that goes side to side here. How many units away is this first point from my x-axis? 3 points away. Okay, you could kind of make a little dash. 1, 2, 3 points away. So we're going to go 3 more away on the other side. 1, 2, 3, and put a point right down there. How many points away or dashes away is my next point on the left of that? 2. So we're going to go 2 on the other side of the x-axis and put my next point. How many away is the next one? 1. So we're going to go 1 more away on the other side. Now my next point is on the x-axis. So how many units away is it? 0. So it stays 0 units away. That point doesn't change. That's where they cross each other. My next point is how many units below the x-axis? 1. So we're going to go 1 above the x-axis. And then my last point that I made is how many below? 2. So we're going to go above 2. Questions about how that worked? Okay, they should cross each other on the x-axis if that's what we're reflecting in. So let's make our line that goes through those points. That's not quite it. That looks better. And we could label this one as g of x. That's the one that they had written for us. Questions about that reflection? Okay, so the last one we need to do is the t of x. So let's talk about that one down here. Here, are we negating the inputs or the outputs? Inputs, because the negation that's in those parentheses, we negate the inputs. So if you had to guess, what axis do you think we are reflecting over? Well, if the last one was x, this one's going to be y. We're reflecting this over the y-axis this time. So we go back to our parent function, and this time, instead of going how many units are we to get to the x-axis, we're thinking about how many units are we going to get to the y-axis. So the y-axis is the one that goes up and down. Let's this time start down here on the left side. How many units away am I from my y-axis? So let's see. It's kind of hard to tell. 1, 2, 3, 4, 5, 6. Okay, so we're 6 units on the left side, so I want to go 6 units on the right side to get a point there. 1, 2, 3, 4, 5, 6. My next point up is how many units from the y-axis? 4. 1, 2, 3, 4. So I want to go 4 units away on the other side. 1, 2, 3, 4. Okay, my next point kind of got covered up. It's the one that's here on the x-axis. How many units is it from the y-axis? 2. So we go 2 more away on the other side. The next point is on the y-axis, so it doesn't move. It's 0 away. It stays there. Now we're flipped over, so now that we're on the right side, we're going to be moving over to the left side. How many units this time? 2. Okay, this red point was 2 away, so we go 2 to the other side. And my last point up here is how many away? 4, so we go 4 away on the other side. Let's see. 1, 2, 3, 4. There we go. And we can put our last line through there. Again, arrows on the ends, and we could label this one as T of X. That's what they called it. Okay, now I know it's a little hard to tell because we have so much on there right now, but if you were to have just looked at it when we had the orange and black lines, those first 2, if you were to fold it along the x-axis, they would match up with each other. It would fold perfectly in half. Similarly, if you ignore the orange line and just look at the purple in the original lines, if we fold our piece of paper along the y-axis, those 2 lines would match up with each other perfectly. That's what it is to reflect. Questions, concerns? Okay, so let's just review a couple more problems. And then it'll be about time to go.
You need to get our homework written down.
Yes, we will make sure we have time for that. This doesn't want to cooperate with me. All right, this is going back to what we did at first. These are going back to translations instead of reflections. So we had 2 big ideas today. Translations, where we move them left, right, up, and down. And reflections is what we just did when you flip it over the x or y axis. So we're back to moving left, right, up, and down. If you want, you can go ahead and write down your parent function. And then we're going to talk about g of x and h of x, and then we'll go through and graph them. So, for g of x, let's just talk about it real quick, and then we'll do all of our graphing all at once. For g of x, are we working inside or outside the parentheses? Outside. So if we are changing things outside the parentheses, that means we're moving what possible ways? Vertically or horizontally? Vertically. Outside, we move vertically. So this is a vertical translation. Because we are subtracting outside, that means it's going to go which way?
Right. No, left.
Remember, we're going vertical, so it's either up or down.
Oh.
Down.
Down. So these get a little tricky. But if it's outside, it's vertical. If we're subtracting, that means it's down. Okay? Let's also talk about our h of x function over here. So for this one, are we inside or outside?
Inside.
We're changing things inside, which means it's moving horizontally or vertically? Horizontally. And because we subtracted inside, that means we're going to the right. Okay? And on both of these, they're changing it by 2 units. So before we can easily change these, it might help to have our parent function graphed. So if we go back to our parent function, what's my m? So my
3 over 1.
good 3 over 1 for my parent function slope. And what about my y-intercept? 1. All right, so once again, we're starting at a positive 1 on the y-axis, and then my slope tells me I can move where? Up 3 and right 1. Or I could go down 3, left 1. Down 3, left 1. Okay, so I've got a few points. We don't need a lot of them, but 3 to 5, maybe even 7 points. 3 to 5 points is probably good, though. I'll go ahead and graph that line. Make it red this time. It's pretty close. Okay, there's my parent function. Now let's graph the first translation, f of x minus 2. So we said we're going to be moving it down how many units? 2. So from every point that I made, I'm going to move it down 2 spots. Down 2 spots, down 2 spots, down 2 spots, down 2. That's all there is to it. These lines are really close together, but we can still graph it. Oh, ooh, that's not great. Let's try this direction. Still not great, but it's a little better. Okay. Questions about translating it down 2? All right, the next one, the h of x, I'll change my color to green. We said we were going to be moving it right. How many units? 2 units. So starting back from our parent, or our red one, we're going to move each point right 2 units. Right 2 units, 2 units, 2 units. And then we can put a line through those. So what's important is that you are able to decide based on what they tell you if it should be moving left, right, up, or down. Do we have questions about this example before we do a general recap? Is that a hand raise? No? Okay, just checking. Okay, so let's just real quick recap some things here. So let's just say we're going to either be adding or subtracting, and we are either going to be inside or outside the parentheses. So this table might help some of you decide how things will move. If we are adding inside the parentheses, which way are we moving? Actually, let's start with outside, because I think outside's easier. If we're adding outside, which way are we going? So we're going up or down. Which one is it if we're adding? Up. If we are subtracting outside the parentheses, we would move where? Down. Now, if we are adding inside the parentheses, this is the one that gets a little tricky. Which way would we go? Left. And if we are subtracting inside the parentheses, we go right. Okay, so this little table might help you keep it straight when you're looking at these to decide instead of looking at the longer notes that we wrote earlier. With reflections, we only got to do one example with that for now. I'm more concerned about our translations, but for our reflections, you just need to know if you've got the negative outside, that means that you reflect over the x-axis. And if you have a negative inside those parentheses, you're going to reflect over the y-axis. So these are just some summary notes that might be helpful to have handy when you're working on your homework. Tomorrow we are going to cover a different transformation style. So instead of lines, we're going to be transforming something else. Having this whole left, right, up, down thing handy is going to help because we are going to use that same idea tomorrow. Anybody need more time with this before I put homework up? Okay, let's make it quick because I got to get homework up for people to copy down. Did you at least get the table down? Everybody's got the table? Okay, because those we just covered that. That's not a whole lot different from how we wrote it in our notes. So, our homework is on pages 151, 152. Now, on some of these, you might not be graphing them. You might just have to explain moves down 2 units. Moves right 2 units. Okay, something along those lines. Reflects over the x-axis, reflects over the y-axis. So not every single one of these will be graphing problems.